right, hey 8th graders, this is Mrs. Shopper coming to you with more Completing the Square. Remember, this is something that's brand new, so if you're still feeling a little fuzzy about it, don't worry about it. We're going to take some more practice. If when we get through this practice you're like, I'm still not sure, shoot me a message and we're going to do a Google Meets, okay? We can work one-on-one or two-on-one, whatever works, okay? So, with Completing the Square, you want to make sure that you get the ax squared and bx on one side and c on the other. So on this very first one, I'm going to start by adding 14 to both sides. So x squared minus 2x is equal to 14. Now what I'm going to do is look at my b. I'm going to cut it in half, which is -1, and then I'm going to square it. And -1 times -1 is 1. So I'm going to add 1 to both sides. All right, so now I have x squared minus 2x plus 1 is 15. I can factor this into two identical binomials, x minus 1, x minus 1. This stays as 15. I can simplify how that's written by writing it as the quantity x minus 1 squared equals 15. From here, I'm going to solve the equation. I'm going to square root it. I have x minus 1 equals positive or negative approximately 3.87. From there, I'm going to solve those two equations. So x minus 1 equals 3.87, so x equals 4.87. And x minus 1 equals negative 3.87. Add 1 to both sides, and I'm going to get that x is equal to negative 2.87. Those are the solutions by completing the square. Reminder, the completing the square is going to come in handy when we're working with circles because, oh my gosh, so cool. You can write an equation, and when you graph it, it's a circle. No lie. Super cool. So hang on to that thought when we get to circles later in the year, but oh my gosh, so cool. Okay. Let's keep going with completing the square. Again, we want to get ax squared and bx on one side. So I'm going to add 1 to both sides. So I have x squared minus 8x is equal to 9. And then I'm going to take my b, cut it in half, which is -4. I'm going to square that, which is positive 16, and add 16 to both sides. X squared minus 8x plus 16 equals 25. Now, the x squared minus 8x plus 16 is a perfect trinomial, so I can write it as the square of two binomials, okay? So it can be broken down into x minus 4 times x minus 4. And if you're like, how did you get that? What two numbers multiplied together give me 16, added together give me -8? It has to be the same number. Taking the square root of x minus 4. Oops, I'm one step ahead of myself. Let me back up. I'm going to rewrite this as the quantity x minus 4 squared, like that. And then I can square root both sides. So square root x minus 4 is positive or -5. And then that gives me two different equations to solve. So x minus 4 equals 5, x minus 4 equals -5. So x equals 9, x equals -1. There are your solutions. Okay? Let's do this last one. In fact, I'm going to get you started on it, and then I'm going to have you pause it. So this is something different than what we've seen before. Seriously, because we've always had, you know, even back on this slide, they all just had a 1 in front. So this is a 2. What we're going to do is we're going to divide everything by -2. So we can get it simplified so we have a 1. So x squared minus 4x plus 9 equals 0. Now what I want you to do is pause the video and do this one on your own. and then come back in and I want you to compare how we did. All right? So pause it. No, really, pause it. Okay, did you pause it? All right, here we go. So what I'm going to do is I'm going to start by subtracting 9 because I want ax squared and bx together. All right. Next thing I'm going to do is take my b, -4. I'm going to cut it in half, which is -2, and I'm going to square it, which is 4. And I'm going to add 4 to both sides. So I end up with x squared minus 4x plus 4 equals -5. Oh, yes. Okay. Then I'm going to put this into two binomials. So x minus 2 and x minus 2 equals -5. And then I'm going to write it as a pair, like that. Now, what do you notice when you square root -5? Did you get an error? Right? Because the square root of a negative number is imaginary. And I don't know if you talked about that last year at all, but the square root of a negative number is imaginary. For example, the square root of -9 is 3i. Now, do you need to know that this year? Nope, you're going to get that next year in Algebra 2, but just so you know. When you have a quadratic equation that you're trying to solve and there is no solution, do you remember what that means in terms of the parabola on the graph? There's no solution. That means that the vertex of the parabola, because these are all quadratics, right? If we graph all of these, they're going to be parabolas. The graph of the parabola has a vertex above the x-axis and it opens up, or the vertex is below the x-axis and it opens down. If you come to an equation that there is no solution, that means that that parabola never crosses the x-axis, ever. Little tidbit about quadratics, okay? So take some time to work on your practice for today. Next thing we're going to move into is systems. Have a good afternoon.